During this video, I'm going to focus on the diabolical ironclad beetle and the underlying physics involved that allows the exoskeleton of these beetles, no, not those beetles, to be so durable and strong. After receiving this assignment, I'll admit, I was a little confused on where I should start. I figured that all the groundbreaking physics research had been done way over 5 years ago and there wouldn't be anything for me to talk about. But then I came across this article titled Secrets of the Uncrushable Beetle. To quickly sum up, this article focuses on research done by numerous scientists to help figure out what makes this certain beetle able to withstand tremendous forces. The diabolical ironclad beetle is a species native to both Mexico and the southern US. They live mostly under the bark of trees and beneath rocks. What makes this beetle so special is the fact that it has one of the toughest exoskeletons of any known insect. This fact became known when collectors tried to mount these beetles to a board, but the pins bent and snapped into pieces. Having the strongest exoskeleton certainly comes with its advantages. Not only can these beetles survive being run over by a car, but they can tolerate forces of up to 149 newtons or 39,000 times their body weight. Although to us humans this may not seem like a lot, to a tiny beetle being able to withstand that amount of force is certainly a phenomenon. So what exactly makes this beetle so special and how can it withstand such incredible forces? Well, that's because of something called interlocking. Using microscopes and other technology, researchers were able to see that the fibers in this beetle's exoskeleton all interlock with each other. The beetle's entire exoskeleton is made up of these interlocking joints which fit together like a puzzle that allows the beetle to be so resilient to heavy forces. How does interlocking help the beetle withstand forces? Well, the main purpose of interlocking is to make sure that all the joints or pieces fit together seamlessly with no gaps. Thanks to this, any force that is applied to something that uses an interlocking pattern is actually spread out throughout the whole surface, rather than only being directed down from the point of contact. Interlocking allows the applied force to go in multiple directions. This dispersion is what allows the beetle to support strong forces. Since the forces go in multiple directions, the whole surface is able to absorb the impact rather than only one individual point. In addition to this, interlocking actually makes it more difficult for the fibers to split away from each other because they lock each other in and it would take an enormous amount of force to undo these joints. As you can see on the beetle's exoskeleton, although the applied force may make contact with only part of the surface, interlocking allows the forces to be directed across the whole thing, rather than only being directed downwards. Additionally, there are forces on the joints themselves that move in opposite directions, making it extremely hard for them to break and expose the beetle. What would happen if the beetle did not have these interlocking joints or fibers? Well, to put it quite simply, no interlocking joints would mean that the beetle would not be able to support the amount of force that it can now. The fibers would split and the forces would not be directed evenly throughout the whole exoskeleton, causing it to break, ultimately killing the beetle. This is the case for other insects who do not have this protective interlocking feature, and that is why they are unable to support the same amount of force as the ironclad beetle. What does this research mean for science? Well, all this work done with the ironclad beetle has allowed scientists to develop structures more durable for aeronautics and construction. They began making models using both plastic and metal that mimic the pattern seen in the beetle's exoskeleton, and found that the interlocking design enhanced the strength and toughness of the materials. If there is one conclusion you can draw from this video, it's that if you want something to be stronger, consider including an interlocking pattern somewhere in the design to help with the resistance to force. Interlocking joints are crucial to insects like the ironclad beetle and other structures that need durability, and luckily it's a physics concept that scientists still continue to study to this day.